Now we're going to look at a very simplistic model of a food chain. It's so simple that we're only going to consider two species of fish. One is the predator and one is its prey. You're going to model the change of either population, the predator and the prey, using differential equations in the form of these equations right here. It's up to you to figure out, however, which of these corresponds to the predator and which one to the prey. There are several other features of this situation that must be taken into account. The prey multiplies at a certain rate. The prey is consumed by the predator. That's kind of a given. The predators, however, only die of old age. And the predator's population also multiplies depending on the amount of prey that is present. Now, in these equations, A, B, C, and D are constants. And in our program over here, you're going to fill in their values in this dictionary called base values. We've already provided you with the values corresponding to two keys in base values. We've included the initial amount of prey and the initial amount of the predator population, measured in tons. Here, however, is some other important information that you'll need to know in order to do this problem. The rate of growth of the prey is 0.5 per year, and the lifespan of the predator is 5 years. In addition, we will reach an equilibrium situation, or a steady state situation, once the amount of prey reaches 5 times 10 to the 6 tons, and the amount of predator reaches 1 times 10 to the 6 tons. You're going to use this information, a little bit of logic, and these equations to calculate A, B, C, and D. Once you enter A, B, C, and D into base values, we'll move down to look at this function called food chain. Here you'll use the familiar forward Euler method to calculate the future populations of the prey and the predator at each time step. Lastly, you'll do a bit of sensitivity analysis. We're going to add in a degree of uncertainty to this problem to make it a little bit more complex. Let's say that A, B, C, and D, as well as the initial amounts of both fish, are uncertain by plus or minus 10%. Similar to your earlier quiz, you're going to create dictionaries for the minimum and maximum values, taking this uncertainty into account, and then determine which of these 6 parameters, A, B, C, and D, and the 2 initial values, has the largest impact on the maximum amount of prey. Again, all of this is very similar to the quiz on sensitivity analysis that you saw in the unit itself, so if you're having any trouble, you might want to review that quiz. And of course, you can always come to the forums for more help. Good luck!